All right, this is example 2. In example 2 here, we are taking an integral of the function p is the integral of r dot dx, and I do have bounds on here between 1 and 3. So I want to know what the integral of this function is. R is this function down here, 4x squared minus 3x plus 6. And so what I need to do there is put this entire function in for r. So that'll give me the integral of 4x squared minus 3x plus c dx. 1 and 3 are my bounds. So first I have to evaluate this entire function. Anything with x needs to be evaluated here. And technically this is x to the first, and remember this is x to the 0 power. So you are going to evaluate those functions as well. So if I do this one, this will become add 1 to the power, divide by new power. Over here, add 1 to the power, divide by new power. And same thing on the last one. Add to the new power, divide by the new power. Now in every integral, you do have to add a constant of integration in. Most of the time, when we do things in physics, that constant does end up going to 0. So for this case, we'll just say the constant went to 0 and evaluate this function here between our bounds of 1 and 3. So that means I've got to put 3 in for each x value. And when you do that, you get 67.5. And now what I need to do is subtract that from what happens when I put 1 in as my bound. So I'm going to put 1 in for every single x value here. X cubed, x squared, and x to the first. And when I do that, I get 8.83. And to evaluate this function between those two bounds, I subtract those two numbers. So 67.5 minus 8.83 gives you 58.67. And that's how you evaluate, using the power rule, this integral.